Okay, so we're gonna do a recording of the solutions to this so that you make sure you have it correct. It's not about copying the pictures, it's about how you can do it. Okay, first of all, Lenz's law. If the object pulls out, if the magnet pulls out of the coil, it will attract. And again, I only care about this end. So what attracts a north is a south. That means this part is a north. We're gonna put our arrow. Remember, it's an electromagnet, so I'm gonna use my dotted lines. And then I'm gonna make my circles. This is kind of like doing the first law backwards. All of these have to match on the inside. That arrow, it's kind of crappy one. And I'm just gonna put 2 arrows in the sense of time because you are just checking your paper. So the bottom ones, again, it says current, so I have to use my right hand. These are going this way, so all of the ones on the bottom are dots. That makes the top X's. And the current always flows from dot to X. So it would be going up the front, down the back. So if you didn't put the arrows on, you need to do that. All right, next one. If the magnet is going in, we know it repels. South, again, I don't care about this end, it's only what's near the end of the tube or the solenoid. If south is going in, it's going to repel. This is going to be a south, this will be a north. Get my dotted electromagnet. My arrow points this way because the tip, well, the north gets the arrow. Let's make my circles. All of these on the inside have to point the same way. And I'm just going to do 2 circles or 2 arrows for right this second. You get the idea. You should have 4. And again, look at the top. They're curling and my thumb is up. So these are all dots. These are all X's. And current goes dot to X. And again, it says current, so I'm using my right hand. I'm going to put arrows like that, letter I. All right, next one. Your EMF, remember we use a squirrely E, is going to be BVL, so it's 2 times 8 times 0.4, so you should have gotten 6.4 volts. Okay, let's see if I can do this last one on the paper. So it's asking for current, which means right hand. My fingers are towards the south. This is the direction that my hand would have bent. So let's see if we get this. My fingers are pointing to the south. The direction of the motion is my fingers, sorry, not the current, because we're making electricity. When I bend my fingers, see my fingertips are pointing to the ground, that gives me an X. All right, let's go to the back. So the first one is kind of a math problem. At what speed? So you're using, EMF equals BVL. You have 15 equals 0.2 times V times 0.5. You should get 150 meters per second. Okay, next one. Let's see if I can do this with my hand. Now it says electron flow, so I need to use left hand. And I'm asking for which way did the wire move. So in this case, I'm giving you the current because I'm induced means I'm making electricity. So my current is my fingertips. Okay, so I'm going to turn the paper so I can do this correctly. My fingertips are going to the south. My hand, the fingers here are the X, so they have to point down. Notice the thumb? I would have had to lifted it this way to make this happen. So it's an up. All right, notice I'm going to do electron flow here. Just means same rule, got to move my left hand. Somebody's moving this counterclockwise. Remember, nothing happens here, nothing. D and B are parallel to the field, so nothing can happen. All right, so I'm going to turn the paper so I can do this correctly. I'm going to use my left hand. I'm ignoring the outers. All right, my finger points to the south. I'm gonna do A, by the way. My thumb is the direction, and when I bend, I get an X. When I do the other one, this one, my fingers are pointing to the south, but my thumb is now, and again, I'm using my left hand. You don't really have to do it, because once you have a dot, you know you have an X, okay? Dots are positive, X's are negative. So A, positive, B is nothing, C is negative, D is nothing. We're going back to A. So your graph, kind of like a cosine graph. Don't memorize these. You have to memorize the process because I can change the letters and mix it up. All right, next one. Again, notice electron flow. I purposely gave you the field and I gave you the direction of the current, which is these fingers. I'm looking for the thumb to know. So I just have to do one of them because that'll get me that. So I'm gonna turn it so I can use, again, it's electron, so it's left hand. So I'm gonna go, again, ignore the outers. I'm gonna point my finger to the south. X means down to the ground. Here's my thumb. So on A, it's up. And then I just have to complete the circle. Over, down, over. And then let's do the graph. A is a dot, or sorry, an X, so that's up here. B is nothing, C is negative, D is nothing, and A, so yes, you get the same two graphs. And then the last one, again, it's an EMF equals BVL, so you have 4,000 equals 0.15 times 20 times L. You should get 1,333.33 meters. All right, that's your solutions. Fix your paper.